Hello everyone, welcome to my YouTube channel. My name is Venon Insofa and I'm a student of medicine at Levi Mwanawasa Medical University. In this video, I want to talk about something that is very important in each and every cell, which is the cell membrane potential. So I want to talk about the cell membrane potential. But what is the cell membrane potential? So the cell membrane potential simply means the voltage difference across the membrane of a cell. So we know that the cell membrane, it is charged. So what is the charge of a cell membrane? So the inside part is negatively charged and the outside part is positively charged. But now, how do these charges comes about? So these charges, they come about due to the flow or to the influx and efflux of these electrolytes that we are seeing here. So the most important electrolytes that we talk about when we're talking about a cell, we talk about sodium ion, potassium ion, chloride ion, magnesium ion, calcium ion. These are the most important ions that we talk about. So now, we know that the cell membrane, it has got channels. The cell membrane has got the proteins, plasma proteins. Some of them, they act as channels through which these electrolytes pass through. So, as you can see, this is a lipid bilayer membrane embedded with proteins. So these are integral proteins. So these are channel proteins, specifically channel proteins. So this channel protein, it is the sodium potassium ATPases. Same applies to this one. So we know that inside the cell, we have got high concentration of potassium as well as magnesium. And then outside the cell, we've got high concentration of sodium, chloride ion. They are more outside the cell than inside the cell. So the extracellular fluid, it has got high concentration of chloride ion and sodium ion, while the intracellular fluid, it has got high concentration of potassium ion than the extracellular fluid. But when you look at this diagram here, you see that these channel proteins, specifically the sodium potassium ATPases, they are transporting potassium from the extracellular fluid into the intracellular fluid, which means that they're transporting potassium against the concentration gradient. Because I've said that in the extracellular fluid, ECF, the concentration of potassium is low. Inside the cell, in the intracellular fluid, concentration of potassium is very high. So we are moving potassium from where it is low in concentration to where it is high in concentration, and that is called active transport. Same applies to sodium. We know that there is more sodium outside the cell than inside the cell. But across or through these channels, sodium is able to pass against the concentration of gradient. So sodium is coming out of the cell, going to where concentration of sodium is high. So this is active transport. And this channel, the sodium potassium ATPases, it is a simple because it is transferring two things at the same time, or another way you can call it an antipode. Two things at the same time in opposite direction. So it is transferring or transporting three sodium ions outside the cell in exchange for two potassium ions into the cell. So have you seen? So here we've got three sodium ions being transported outside against the concentration gradient and two potassium ions being taken inside the cell. So we've got a difference of one ion. So this is going to cause the charge imbalance between the outside ECF and the inside ICF. So these channels, they use energy. They use ATP. That's why they are called sodium, potassium. That's why they are called as sodium, potassium, ATPases. Because they use energy. So these channels that we're seeing here, they're called sodium, potassium, ATPases because they use ATP to transport these ions or these cations, sodium and potassium, against their concentration gradient. So as sodium is leaving outside the cell, it's going to leave holes there. Or in other words, it's going to leave a negative charge because we are getting two potassium into the cell while losing three sodium outside the cell. So there's a difference of one, right? So what's going to happen is that we are going to have more positives outside the cell and less positive inside the cell because two are entering, three are going out. So we are going to have more positive or more cations outside the cell and less cations inside the cell. So which means the cell is going to be positively charged outside and negatively charged inside. So the cell is going to have a positive charge on the outside. The charge is going to be positive on the outside of the membrane and negative inside the membrane. So the charge that is going to be created or the voltage difference that's going to be created is going to be negative 5 millivolts. So negative 5 millivolts. So this process or this movement of sodium ion and potassium ion across the cell membrane, it creates the voltage difference of negative 5 millivolts. Now, we know that sodium and potassium can also get in the cell and go out of the cell using another process which is called diffusion. Because now, just from talking about active transport, so active transport is done through sodium potassium ATPases. Now, sodium and potassium ions can be also transported through diffusion. So in a cell, there are what we call leak channels. So we've got what we call the potassium leak potassium channel. So this one, it is called leak potassium channel. And then this one, it is called leak sodium channel. Leak sodium ion channel. So now, what do this channel do? So these channels, we know that they are there to transport sodium ion and potassium ion. into the cell and out of the cell respectively. So we know that inside the cell, there is a high concentration of potassium ions than outside the cell. So what's going to happen? Potassium ion, it's going to start leaving the cell, going to the outside. But potassium ion, where it is in the cell, because we know that the cell itself, it is neutral. Because why is it neutral? Because the positive charges and negative charges, they cancel each other. Okay, so inside the cell, potassium ion, it binds to chemicals or to substances, to be more precise. So it binds to substances. So what are these substances? So the substance that it binds to, we talk about phosphate groups and the proteins. So the amino acids of proteins, they have got negative charges. So the amino acids have got negative charges. So here inside the cell, potassium ion, it binds to substances. Let me just label them as A. So it binds to substances so that the cell becomes neutral. So each and every potassium ion inside the cell is paired. It is paired with a negative substance. That's why the cell is neutral. So these substances, they can be a phosphate because phosphate groups are negative, and also they can be proteins because proteins are made up of, they're polymers of amino acids, and amino acids, they're negatively charged. So now what's going to happen when potassium, because we know that there is more potassium inside the cell than outside the cell. So what's going to happen when potassium starts leaving the cell? So when potassium starts leaving the cell, what is going to happen is that there is going to be unpaired negative substances. Okay, because like I said earlier, each and every potassium ion inside the cell, it is paired with a negatively charged substance or negatively charged particle. Now, imagine that these, they dissociate and potassium start leaving the cell. Potassium ions start leaving the cell. So some substances, or let's say phosphate group, or some proteins are going to remain unpaired. And they are going to create a negative charge inside the cell because potassium is leaving outside the cell through what we call leak potassium channel. So as it is leaving inside the cell, it is creating a negative charge. So this negative charge that is being created by sodium potassium ATPases is going to be strengthened when potassium ions start leaving the cell. So these potassium ions, when start leaving the cell, they're going to strengthen the charge now. So the charge is going to increase. Because you know that initially, this only creates up to negative 5 millivolts. So this is going to increase this. Okay, so when it increases, what is going to happen? So the cell inside, we're going to have more negatives inside than what? Than positives. More anions than cations. So what is going to happen? So here, the potassium ion, it is moving down a concentration gradient, right? Because we've got more potassium inside the cell, more potassium ions inside the cell than outside the cell. So potassium is leaving down a concentration gradient. But when potassium goes outside, potassium ions, when they go outside, they're creating or they're leaving a negative charge inside the cell. And these are cations, they're positively charged. So these negatives, they are going to attract the positive ions which are living outside the cell. So they are going to attract these positive ions. So these like partners, like girls, they're going to attract these males. Hey, come back here. So this is what they are going to say. These negatives, because they remain unpaired. They don't have partners. So they're going to create a negative charge, which is going to attract these cations back into the cell. So now, potassium will now start moving down what we call an electrostatic gradient or membrane potential. So potassium will start going back into the cell. So there's going to reach a point where the amount of potassium leaving the cell and the going out of the cell is going to be balanced. That's what we call resting membrane potential. So the same thing happens to sodium ion. We know that there is more sodium outside the cell than inside the cell. So sodium ion will be moving into the cell. But the movement of sodium ion is very slow as compared to potassium ion. That's why there's an imbalance. So this movement of these two ions will increase this part. So in other words, it's going to hyperpolarize the cell membrane from negative 5 millivolts to what? To negative 50. So from negative this to negative 50 millivolts. So it's going to be hyperpolarized. So this is what we talk about when you say resting potential membrane. So you should check another video that I'm going to post very soon, where I'm going to explain now about the action potential, graded potential. I'm going to make a video very soon. Make sure you subscribe to my YouTube channel if you want to understand more on this. Thank you so much for watching the video.